Hello everyone, welcome back to my YouTube channel. In this video, we are going to discuss one of the most powerful concept in agentic AI, the multi-agent collaboration design pattern. So here we talk about what is multi-agent collaborations, how multiple AI agents communicate, coordinate and divide responsibilities, and the role of planner, executor, reviewer and critic agents, and how this pattern involves accuracies, scalabilities, and decision making in complex systems. And then after that, a small real world use case in rack systems, autonomous workflow, and enterprise AI platforms. So by end of this video, you will have a clear architectural understanding of how to design and deploy collaborative agentic systems in production. So without further delay, let's get started. So multi-agent collaborations, multi-agents. So what is it? So multi-agent collaboration is a way of designing AI systems where multiple agents works together as a teams instead of single large model doing everything. It's think of building an AI organizations, not a single AI brain. The core idea behind is instead of asking one AI to understand the problem, plan the solution, gather the informations, and reason deeply and produce the final answer. So we divide the work across multiple agents, each with a specific responsibilities here. And next and then next now we breaking down the definitions. Multiple specialized agent work together. What is it? So each agent is designed to be a good at one things. For example, a research agent, it finds and summarize the informations. A reasoning agent analyze and connects idea. A writer agent, it convert the insight into clear text. So this improve accuracy, focus and scalabilities. Next is each agent has a distinct role. So each agent has a clear role and define the scope of responsibility and a specific output format. This avoids confusions, overlapping works, and hallucinations caused by unforced prompts. For example, financial agents, they look only at a revenue, profit, and growth. Risk agents only identify threats and uncertainties. So a manager or orchestrator agents coordinate tasks. So manager acts as a team lead. It's a job. It's job that understand the user overall goals. It's break into the smaller tasks, assign tasks to the right agents, monitor progress, and combine result into one final output. For example, we need to analyze the Apple business strategies. Okay, so manager agent says assign market analysis to the market agents, assign financial review to the finance agents, assign risk analysis to risk agent, and this introduce a planning and control which a simple prompt system lacks. So agent communicates via shared memory and or messages. So agent need a way to share the knowledge. This is done using shared memory, common knowledge to store, and second one is the messages, direct agent to agent communications. So shared memory contains immediate results. It's having the key findings, facts, and assumptions, and decisions already made. So why this is important? So agent don't repeat works. Everyone stay aligned and output become constants. So shared memory is like a company Wikipedia or shared Google documents. So in one line I can say the multi-agent collaborations is an AI design pattern where a manager agents coordinate with a specialized agent that work together using shared memory just like a human team solving a complex problems. Now talk about the core components. So A multi-agent system works because each component has a clear responsibilities. So there are three essential building blocks here: manager, manager agents, role-based, specialized agent, and shared memory. So manager orchestrator agents. So manager agents is the brain of the systems. It does not do all the work itself. Instead of its plan, coordinate, and controls and other agents. It's think of it as a team lead or a project manager. Responsibilities: it understands the global goal, read the user request, understand the final desired outcomes, and then it break the goal into subtasks, decompose a large problem into smaller and logical tasks, and then it assign a task to the role based agents. So choose the best agent for the task, ensure a specialization is used correctly, like market agents, market task which assigned to research agent, finance task assigned to the financial agents. Right. So next, the track progress. How to do progress. So it monitors which tasks are completed and detects delay or missing output, and it resolve the conflicts also. It handles the contradiction between the agents, and it decides which output is more reliable, and it merges the all the output in a final results, and combine all the agents output and produce a coherent and unverified answer for the users. So the role based agent, what is the importance of here? So role based agent are a specialist, each each designed to be done one type of extremely well. They do not make global decision and plan the entire workflow. So how agent is optimized? So the role specific system prompts that clearly define what the agent should and should not do, like API search, search tool, calculation, code interpreters. Next is shared memory. So shared memory is a common knowledge space that all agents can read from, write to. It ensures the alignment and continuity across the systems. It's think of it as a shared company knowledge base. So what shared memory that enables? So shared memory enables the knowledge persistence, cross agent awareness, where agents know what others have done the works, and it reduces the duplicacy, no repeated works, long term reasonings that enable the multi step thinking. So it had there is a multiple type of shared memory. First is short term. So it talk about the task progress, intermediate output. Next is long terms. So it talk about the knowledge base and the documents. Third one is episodic memory. It's run fast runs, success, failures. And next is two states. This is the API results, logs. It's talk about the API results, logs, code outputs. So for example, research agents writes a market data to memory, financial agents needs reads company detail from memory, manager reads all the insights to synthesize final outputs, and then memory prevents agents from the working in isolations. This is all about the core components. Next is agent interaction flow. So this flow describes how a multi-agent system moves from a user request to a final answer is a structure. So first is user goals. It started with user goals. So the user provides a high level objectives, not instruction for each steps. Then manager agents. So the manager or orchestrates agents receive the user goals and become responsible for the entire workflow. Then task decompositions. The manager break the big goal into smaller logical subtasks. Then rule alignment. Then the manager map each subtask to the most suitable specialized agent. So a specialized agent parallel. So it's talk about its work agents. A specialized agent work independently and in parallel on their assigned tasks. And then shared memory. So here what happens, so it read existing context before acting and write the output after completing the task. So shared memory stores facts in intermediate calculations, assumptions, and tool outputs. Next, manager aggregations. So the manager reads all the agent's output from shared memory. It resolves the contradictions, check the completeness, it validates the qualities, and then final output. The manager produces the final user ready response that is in a steady structure, constraints, and grounded in shared, uh, shared proofs. The user see one clear answer, not the multiple fragmented answers. So this is the flow. So if we talk about one example into example, so user is giving the goals like analyze the Tesla business outlooks. So the flow looks like the manager plan the task in, and then agent analyze market, finance, and risk. After that, memory stores insights, and the manager merge results, and final report is delivered. So the agent interaction flow turns a high level user goal into a coordinated multi-step coordinations where a specialized agent worked in parallel, shared knowledge, and are guided by manager to produce high quality final outputs. So this is the one example company research agent. Will explain the step by steps. So first is the user prompts. So the user prompt is analyze Tesla business outlook. So the prompt is broad and complex. It involves a multi-dimension market, finance, and competition and risk. This makes it ideal for the multi-agent systems. Second one is the manager agents that decompose the task into the multiple parts, and the manager orchestrate agents receive the prompts and take ownership of the task, and it decompose the request into the structured subtask like market trends, then EV market growth, consumer demands, technology, whatever the market information we have. Similarly, financial information talk about the revenue, profitability, cash flow, etc. And then competitive risk like go with the competitor, regulations, supply chains. So it's break the complexity into a manageable parts. A project manager planning research alignment. So it's talking about this point is talking about this manager agent is talking about like that. Third one, a specialist agents. So each subtask is assigned to the specialist agent with domain expertise. So market agents, it's definitely talk about it's will do the market analysis. Finance agents that will talk about the financial data. Risk analyst will talk about the risk assessments. And fourth is the shared memory. So all the specialist agents write their findings to the shared memory, like marketing agent, finance agents, risk agents. So whatever their findings, they are going to write in the shared memory. So all the writes, it's manager reads consolidated memory and then write agents. So the writer agent read the consolidated insights and it converts the structural finding into a clear human readable reports. It produces the final reports. Next is, so this example, right, company research agent systems. This example shows that how a manager-led multi-agent systems decompose a complex business analysis into a specialized task, coordinate parallel agents with the help of shared memory, and synthesize the result into a high quality final reports. So few of the principles we will talk about agentic design principles. So these principles define how to define reliable, scalable, maintainable multi-agent systems. They prevent chaos, hallucination, and brittle workflow. First, separation of concerns. So one agent is not equal to multiple skills. One agent should be with one skills. So one agent, each agent should have do their one type of jobs. Focus on one responsibilities. Avoid mixing related tasks. So agent, the agent should not do research. One agent should not do research, analyze, write, validate all at the same time. So if I do one agent do the research, finance, writing, and queue, this is the bad designs. Good design, we are assigning a separate work to the each agents. Like research agent, we are is talking about to collect the data. Financial agents, they talk about analyze the numbers. Writer agent, that write narratives, and then QA agents validate the correctness. So for example, the real world example is that, so a doctor does not perform surgery, run a lab test, and a write insurance report alone. Second one, explicit contracts. So agents must have clearly defined contracts. So the contract define inputs, what the agent receives, output, what the agent must produce, and failure condition, what the agent should report failures. So memory is the first class citizens. So memory is not optional, it is the core system components. So agent must read before acting, understanding the context and avoid duplications, and right after acting, it persisting the findings and shared knowledge. So why this matters? If we go with without memory, so agents repeat works, output are conflicting, and long term reasoning fails. If I go with memory, then knowledge accumulates, decisions improve over time, and multi-steps workflow become possible. So memory is a shared company Wikipedia. Tool isolations. So not every agent needs every tool. Each agent should have access only to tools relevant to its roles. Minimal permissions is provided there. Next is coordination patterns. So coordination pattern define how agents interact with each other and with the managers. Choosing the right pattern depends upon on the task complexity, derived desired controls, and systems scale. So manager lead hierarchical. This is the most common. See, this is the I gave manager, and manager is agent A, agent B, agent C here. So the manager agent is in charge. The specialist agent only act when the manager assign the task, and all output flow through the managers. So what is the strength here? It having the manager having the strong control. The manager oversee the every actions, and it is very easier to debug. And what is the weakness? Is less autonomy is here. Agent cannot be self confident. Agent cannot be self coordinate. It can slower the it can be slower due to the sequential dependencies. Next is blackboard, memory driven. So agents Shared memory agents. So agent communicate indirectly via shared memory. Manager may still supervise but does not control every steps. So agent read from and write to memory asynchronously and collaborate emerge from the shared context here. Right? This is the flow. This is the flow I'm talking about. So what is the strength here? So agent can dynamically reach to others output, and it is very flexible, so agent can self-organize and around the task. But here is a weakness here. It's hard, it's very little hard to reason because emergent behavior is unpredictable. A risk of conflicting output without careful validation here is happening here. So little problem is here. So for example, the researcher, multiple researchers write into a shared Google documents, reacting to each other's notes without explicit instruction from the managers. Next is peer-to-peer agent, then agents, agent forward and backwards. So agent communicate directly with each other. No central managers. Decision making is fully distributed. So it helps to agent self coordinate, and it's adding more agent does not bottleneck the systems. It can handle highly distributed tasks. So this is about the coordination patterns. Yeah. Now we can talk about when to use this pattern, this design patterns. So multi-agent systems are not for every task. This is a scenario that required required coordinations, reasoning, and specializations, but are overskilled for the simple task. When to use complex when situation where it is excel in complex reasonings, that tasks are required deep analysis across the multiple domains. Multi-steps workflow tasks are involved sequential or parallel steps where high accuracy is needed. Situations where error are very costly. Tool heavy use, the tasks that require the multiple tools, API or external data source. It is avoid in a simple Q&A where a single LLM agent can answer directly. Multiple agent orchestration which add unnecessary and complexities. Single step task. So no need for task decomposition, memory or multiple agents. A single agent systems are faster and simple. This is the architecture flow of multi-agent collaboration in agentic design patterns. So it starts from user prompts. So user prompt is analyze the Tesla business outlook. So the process begins with the user providing a high level request, and the system need to understand what the user want to achieve. Next is step 2, manager agents here. The manager receives the user prompt and it becomes the orchestrator. The responsibility is shown in the diagram here: task decomposition, role assignment, rule result aggregation, conflict resolutions. So the task decomposition is a split the big goal into smaller subtasks. Role assign each subtask to the appropriate specialist agents. Results combine output from the multiple agents, and conflict handle any contradictory or missing informations. That ensure that these steps ensure that each part of the task is handled by the right expert and the final output is coherent. Next is a specialist agents. So manager agent, market agents, that is in orange color, that do the market analysis. Finance agent that do the financial analysis, and risk agent do the risk assessments. And then The shared memory. All the agents read from and write to the shared memory, which act as a central knowledge store. The content of memory is knowledge base, interim data, and tool outputs. So it ensures the cross agent awareness, it prevents the duplications, and allow the manager to aggregate result efficiently. And then finally is go to the right agents. The right agents, the purple one, read all the insights stored in the share memory, and it converts the structured output into a coherent final reports, and then it generates the final business report to the Tesla. The user receives a high quality structured and evidence based analysis without needing and interacting with each specific agent individually, right? So if we talk about the flow summary, so the user agent, then manager agent. So manager agent having the decompose, assign, and aggregate. Then it goes to the specialist agent like market, finance, risk. Then it goes to the shared memory, which having stored all the insights, and then write agents generate the final report, and then final output to the users. So the manager coordinate, a specialist executes, memory store, write, synthesize, and parallelisms plus here is the share memory improve efficiency and accuracies. So this is about the architectural flow. So one program, simple program, I just executed, and this is the program I have. So this is the shared memory. This is the multi-agent company research system simulations. So this is the shared memory. So this class act as a central memory. Agents store and retrieve the informations, write the key value. It stores the result from the agents like market analysis, and read the key, fetch the specific piece of informations, and read all, get the everything in memory, right? Next is a specialist agents. So these are the specialist agents we have: market analyst agent, finance agents, risk agents. So the market agents provide the market insights. It The finance agents provide the financial insights. Risk agents provide the risk assessment insights. And this is writer agents. So it's aggregate the information from the shared memory. It combine market, financial, and risk insight into a formatted reports, and act as a summarizer or synthesizer agents. And this is the manager agents. Manager agent orchestrate the workflow that retrieve the uh, user prompts, receive the user prompt, assign task to the specialist agent, store result into the share memory, and it call the writer agent to generate the final reports, right? It's calling, we are just calling generate reports. Okay, and then this is the main program where I'm providing the, this is my user prompts. So if I run it, so see, this is the manager received user prompt, analyze Tesla business outlook. Manager decomposing decomposing the task and assigning to the agents, and then market agent for market analysis, finance agent for financial analysis, risk agent for risk assessment. And this is market analysis, store the data into the shared memory, similar way, financial analysis stores the data into the shared memory. Risk assessment store the shared data into the risk memory, and then manager finally the aggregating results and generating the final reports, and then writer agent generate the complete information. So Tesla business outlook report. So this is the market insights. So EV is growing 20% year to year, increasing adoption in US and Europe. Financial insights, revenue is $80 billion, profit margin 10%, cash flow. Is talk about the financial information. A risk analyst is saying regulatory changes and completion may affect the growth, supply chain and risk moderate. So this agents, this is the agents output. So multi-agent systems. So each agent has a specialized role. Manager coordinates with each of them, and then ensure that the agent can share the information into the shared memory, and also the manager split the task and agent execute and manager aggregate, and yeah, the final report has been generated. The coherent report is generated. So this is all about the one example I just collected and executed. So that's all from my side. Thank you for the today. If you like this video to understand multi-agent collaboration, agentic design patterns, don't forget to like, subscribe and share. See you in next one. Thank you.